Assalamu alaikum. Dear students, let's now continue with the second part of the lecture on chapter 6, which is predefined functions. And in this particular section, we're going to talk about some of the codes that are present. So let's start with some of the examples. Let's start with the class average example. So in this case, what we observe is, again, a program that compares different class averages. So this program computes and compares the class averages of two groups of students. So there are two groups of students and it wants to compare the class averages of both. If you go inside, again, you've got the some of the header files. These are the, for example, the precursor directives for IOStream, for IOMAN IP, for file stream, for string. Then you've got the using namespace std. Then you've got two of your prototypes. These are the function, what we call function prototypes. So here you see that we have got a calculate average function prototype, which has an if stream address of input. So this is a reference variable that takes the address of the input stream. And then there's a course average, which takes a double variable. It again takes the address, and you can notice that they're both void. So if you want to change two values at a time, you're going to use a void function with a reference parameters. That's a good programming practice, and that is something that I'll recommend you to use as well. The other side is where you basically print the results, again using a reference parameter, a simple parameter, and a simple pass by value parameter. So these are value parameters, these three. This is a reference parameter, and both of them are not returning anything. On the other hand, these two are both reference parameters. So in the main function, we basically have a string course ID. We then have another string course ID 2. We have an integer by the name of number of courses. We then have a double average group, double average group 2, if stream group 1, if stream group 2. And then you have an output file stream, out file. The group 1, if you open the group1.txt file, that's what you do here. So you can basically open it out and you observe that, you can basically open it using group 1. Group 1 is basically, if you see, this is an if stream over here. So input file stream group 1. So group 1 dot open file. So this opens this file group 1.txt file, which is this one. And you can see it has got CSE, English, history, maths, and physics scores of all of these for the whole group. And the other file is basically group 2, which contains the result of every single person, and it ends with -999. So that is the sentinel ending, I think. So whenever you encounter the first -999, you're going to stop there. Anyway, what it does is that it opens both files. If either of the group did not open, we should actually stop here. Since we are unable to open file, return the error and stop. Otherwise, we'll continue, since that means that both files were present and have opened. So in that case, we then now open this file student.out for output purposes. Output file, in that we basically fix the manipulator, which is then followed by after fixing the manipulator, we can then start with average of the group 1 and average of the group 2. So the number of courses are 0 at the start. The output file is written as course number, group number, and course average, followed by the next line. Then we have got group 1. You're writing into it course ID 1. Into group 2, you're getting the course ID 2. So you get the course IDs for both the groups, right? Since group 1 and group 2 are both the input streams. So you get the course IDs from both of them. Then until you get more results from group 1 and group 2, you can keep on running this. So if course ID 1 is not equal to course ID 2, we see that data error, course IDs do not match, and hence the program is going to terminate. The courses need to match together. And if they match, then we need to calculate average. So this is the function call where we make function call for group 1 and average 1. We also make the function call for group 2 and average 2. So look, what is happening here is that by just making these calls, we are kind of safe and sure that the function calls have been made and the values will be returned directly. For print results, well, when the result is going to print it, this is a third function call. We provide it an output file address. We then output the course ID 1. We give it the group 1 name and the average. So these three are, as you can see, are going to be values that are going to be passed. This is a double value. this is an int value, and this is also this is basically a string value. So we noticed that 3 different data types are being passed to the print result function. These ones, whatever changes you're making in these, will not be made actually to these ones, but to the copies here. So not the original values will remain the same, but the copies will change. On the other hand, the output file, whatever that is, since this is an address, so the changes will be made here. But this is a memory, so this will be, the changes will be made in the actual output file. And we print results, all of them were returning void, if you remember at the top. So these were all void functions. Print result and calculate average are both void. So you call the calculate average function twice here, while the print result function twice as well. So both, you can call a function as many times as possible. This is what we call the function call. This is how it looks like. And then in this function call, what we notice is that calculate average actually has 2 variables. These are the formal parameters. These are the actual parameters, group 1 and average 1. In formal parameters, you can see that we actually had an if stream, INP, and a double course average. And these are both the addresses of these things, right? So these changes are going to be real changes. So group 1 and average 1 are real. Group 2 and average 2 are going to be real changes. While of course group 1 is where we write, group 2 is where we write, average 1 is the actual variable value that will be returned back. We can see that it is a double. Also notice that if you look at this, we cannot identify if this is a pass by reference or a pass by value. So this is this a value parameter or is this a reference parameter? I cannot identify from here. The only way I can identify is by looking at the way it is declared. So here I notice that there's an ampersand sign here. So this is a reference parameter. This is also a reference parameter. This is a reference parameter. However, this one, the course ID, is not a reference parameter, but it is a value parameter. Similarly, group number is a value parameter. Average is a value parameter. If we go out and if we look down, average group 1 is equal to average group 1 plus average 1. Then we just need to calculate these values. And notice that we're directly using the average 1 and average 2, right? So we're just using the averages directly. And then we are just going to store them in average group 1 and average group 2. And number of courses are going to increment it. And the thing is then going to continue on. For this course ID, we just write out the course IDs out there and then continue on until we reach the end of the while loop where either group 1 or group 2 basically stops. If the stop is basically on the same thing. So let's say that if group 1 ended, or if group 1 was still present, but group 2 ended, we'll notice that this one breaks. So this actually means that there's something wrong with group 2. So we ran out of data for group 2. And in this case, we cannot compare again. So this is something wrong. Otherwise, if group 1 actually ran out of data, we can say that here, that we ran out of data in group 1 and not in group 2. And similarly, otherwise, if we ran out of data for both simultaneously, this means that both are right. So now we can output the file simply by saying that average for group 1 is average group 1 divided by number of courses, new line, and average for group 2 is this divided by number of courses and end line. And finally, you need to close all the 3 files and finally return 0. But if you go down, so this is the body of the main function and this is done. This is how the main function here got executed. However, the interesting part lies down. So here is the body of the functions for calculate average and for print result. Notice that we use the calculate average and print result in the main function. So one way of doing that is to declare the whole body before here, right over here. Then you don't need to have function prototypes. The better way and a more professional way is to use function prototypes at the top, followed by the main function, followed by the body of the functions. So here's the body of the function, calculate average. Notice how small this function is. All it does is it calculates, it takes some input. These are the formal parameter lists. It's a void, so it does not return anything. The name is calculate average. That's what is used above as well when you used a call to the function and along with the actual parameters. So now you have, these are some of the local parameters, total score, number of students, score, etc. And this is the body of the function. It does something while until you don't get a score of -999, you'll keep on taking the total score, you'll keep on increasing the number of students, and you'll keep on getting the next score, right? So that's how it's working. INP is the name here. Notice that the name here is INP, right? But the actual name that we had used there was basically group 1 or group 2, right? So when we pass the value, we pass them group 1. But when it comes here, it then becomes INP. Since this is by address, so they're both the same and the changes are made in the same file, in the same address. The course average here, it's course average, right? If you go above, it's basically average 1 and average 2, as I remember, right? So here it is average 1 and average 2. So average 1, the value is passed, but since it's the address, so the address is passed. It's not the value. And this is a reference parameter. In reference parameter, the changes that are made here are visible in the main link as well. So it's visible in the average 1 directly. That's why when we used average 1 here, the value has changed. It's not 0 as declared at the top anymore. Okay, right. So that's how this function is running. Similarly, you have got the print result, which does it in a particular manner. If its group number is 1, we then have this. Otherwise, if it's group number 2, we have a different way to output it. And finally, we set particular weights, particular group number, check width, average, and so on. So this is how you print the results. And this is the end of the print result function. This is the end of the calculate average function. And this one here should be end of the main function, which is not mentioned here, right? But I'll do that. End main function. Save it for future references. Okay, so that's the first one. If you run it, I want to delete student.out first. So this is already there, the result. Let's delete it actually. And yeah, I want to move to trash. Do not ask again. Thank you. This is now deleted, as you can see. And now if we run the code for this particular example, we'll notice that we'll ultimately get the file at the end. Come on. Takes a bit of time, but while it's running, I think now it's complete. And now we can see the student.out file. It contains exactly the same file in the proper format for those input files. So this is the result that we get after running this program. Notice that this is a bit complex for you, more complex than what you have already seen. But with functions, life does get a bit more complex. So let's see the other program. So this is the same program, comparison of class averages. This program computes and compares the class average of two groups of students. Output is shown as bar graphs. Okay, so now we also have got bar graphs. So some part is exactly the same. However, the result is now shown as bar graph. In the case of print result, we actually see something very interesting. So that function is changing, print heading is changing, and that's what it is doing. So let's see the result for this. What is the result after we run this? It's again student.out, so I'm going to skip this. I'm going to delete this one. Delete. I don't want student.out now. Let's see what happens when we run this. So notice here that we have got 3 programs now. One of them is calculate average, the other is print result, and the third one is print heading. So these are 3 functions, again with reference parameters and with value parameters, and we just need to run it to see what happens. So just run the code. And the result for this, we have now got student.out again, and you've got, student.out. Let's see what the results are. So here is the result. And now this looks like a bar instead of numbers. So for example, group 1 has got, is represented as 4 sterics. The group 2 is represented as 4 hashtags. And we see that in physics, for example, they're exactly equal. In other cases, they may differ slightly from the other group. So this is just one example of a slightly more complicated code that does the same thing, but is really nice to work with, right? So we can kind of see the whole program, and that's a different thing. Okay, so let's go to the next example, which is a program that classifies number. This program reads 20 numbers from and outputs the number of zeros, odd, and even numbers. Read 20 numbers, zeros, odd, even numbers. Again, initialize zeros, odd, evens. This is a function that basically does something. Again, you can see the prototype here, initialization, get number and classify number, and print results. And each of them has their own data type. So these ones are basically passed by reference or reference parameters, as we can see. This one is also reference. This one is not a reference, but by value. These ones are again reference, while these ones are all value parameters. And hence you have got the main function with which you start after the prototype. And in this main function, you have got variable declaration. You call the initialization function. You then call you perform something, you call get number, you call classify number, you get the print results for zeros, odds, and evens, and finally you are ending the program. So how does initialization look like? Well, initialization looks like actually zero count is initialized with 0, odd count is initialized with 0, and this, since they are by reference, so the changes that will be made here will be made in the actual parameters that are passed into initialize. So zeros, odds, and evens will all have value 0 after you print it or after this, right? And you can check for that. So then you've got the get number function, which gets the number the number from the user. You can write it directly over there as well, or use a function. In this case, they've used a function. This change will be made in the actual number. Then you've got classify number, which is basically again changing 4 things. The number will not change, but everything else, zero count, odd count, and even count is going to change. So you switch basically you switch to the num%2 if it is 0. Then you increase the even count. If it is exactly equal to 0, you also increase the 0 count as we did before. Otherwise, if it is 1 or -1, increase the odd count, and that's the end of the program, right? Of this function, not the program, but the function, classify number. Similarly, for print result, you have got some statements in there that are to be executed, and that's the program in a nutshell. I'm not going to run this program now, but directly go to driver and stubs. So this is an example of drivers and stubs. And what we have here is a constant double, 3 functions that have got some parameters that are to be taken. And you can notice that this is the value returning function, and these two are basically void functions, right? And this is a constant. That is, as I mentioned, it's a good habit to always do it in all caps and separate it with the underscore. So let's go to the main function now. Main function actually has some things going on. Yeah, pretty standard stuff here, input, output. Then the function call is made for pool fill time. Notice that only pool fill time is called, not neither the pool capacity nor the print is called, or print is also called here, but pool capacity is not called. And in pool fill time, you first start with the body of the pool capacity, which I think takes in length, width, and depth, and basically calculates the volume and the pool water capacity. And then returns the pool water capacity by using the volume into gallons in a cubic foot. And basically, yeah, so this is the one thing it is returning. Then if you look at the pool fill time, the time it takes to fill the pool, it has to be dependent on the pool capacity. So first you calculate the full pool capacity, and then you basically divide it by the fill rate plus 0.5 to basically determine the fill time for the pool. And finally you get the print thing. So we notice that print is called here, pool fill time is called here. The pool fill time actually calls the pool capacity function inside it. So we notice that a function calls a function to get something done, and that can be used a lot of times. So you can call functions from the main, you can call functions from within a function, and so on. So this is all very interesting and very important that you know when and how a function is called can be made and how it can be made. So this is an excellent example that you need to run on your own as well to understand what's going on in there, right? So maybe you can execute this one. And the question that is asked is, enter the length, width, and depth in this. So let's say 40, 40, and 40, right? So that's this in gallons per minute. So let's say the rate of water that is being filled is let's say 40 gallons per minute for a start. So the time to fill the pool is approximately 199 hours and 28 minutes. It computes everything, right? So that's the beauty of this particular program. Notice that in this case, we had a main driver, and then there were other stubs that were being used. So the calling function, main function, asked the pool fill time. The pool fill time actually asked the pool capacity function to perform something for it. The values when returned were returned here. That is being filled into the pool water capacity. And after it got filled, then we just calculated using this particular static cast and the formula for it. And that gave us the fill time. That fill time was just printed out by dividing it by 60 for hours. And basically fill time, the remainder is shown as minutes. That's the whole program in a nutshell. So moving on to the next example, which is example 5 code. Again, I can do the same. Basically, a constant declared, a double rectangle is a function rectangle. Notice that it has include IOMN IP right after it. This works, I think so. That's not the main problem, or maybe it does not. Okay, it says the switch statement is incorrect. So this is an example of where things can go wrong. And this is a syntax error here. So a lot of errors in this program that you might typically make. You don't want to have function declarations here. You don't want to miss a semicolon. This is not the right place, and so on. So lots of these errors are present here that you need to identify and fix in case you're given a program to do so. And this is something that you should be aware of how to fix this one. So there's something that are not allowed. For example, I see that a choice is used here, but it's not declared here. So it's declared somewhere else. You need to fix it. Yeah, call this fix, make this choice before, and so on. So this is an example of code that has certain errors, and we need to remove these errors. These are all logical or syntax errors that needs to be taken care of. This is an example for external variable, and external variable, for example, you declare extern int w, and this is also extern int w. And this is an example where we're going to use int w. So int w was declared here, but we noticed that since this is not declared before it, we cannot use it as a global variable at all. The only way we can use it by using the constant word extern with it, and then it becomes accessible to over here, although it is declared at a later stage. And yeah, so on. So in case of this, if you want to use int w, either declare int w before int main right here. So that's a good way. If we use it here, I think it will still be just fine. So maybe int w declared here, and then I don't think so you need to declare. You can maybe comment this out, and it is still not going, this w is not going to give an error, right? But if you actually do not use, for example, and yeah, this needs to be commented out because you've not declared w at the top, right? So this can be declared out, and now you don't need to mention the term external, and maybe directly use it wherever it is required. That works absolutely fine. Remember that a global variable acts just like a static variable. It won't be removed from memory until the whole program basically ends. Uh, so yeah, that's about it for the external variable here. Quickly go on to the for loop scope, and here what we notice is that int I is equal to 0. So I, the scope of I is here. This is the problem with the scope, this I. So there's this I, then there's this I. So this variable I is basically, if you run it, right, it basically gives the output 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 star X and this. So we noticed that although you had two I declared here, but I is equal to 90 did not affect this one. It only started from 0, went on till 10, and it got all the values of 0, 1, 2, 3, 4, 5, 6, 7, 9. Then you see out the value, you see out all the values, and you perform an endl, and finally here is where perform I plus 2. And when you actually perform I plus 2, this adds 2 to the I value 90. This I is not visible to this part because the scope of this particular int I is only this line actually, and not beyond. So this I is visible everywhere else. This I is the one that is going to be called and used over here. There is a question how to use this I over here, and I think that's not possible simply because uh, this one is now the local variable, and this is not actually local to this particular point. So here's another example of a secret entire that we discussed in the main lecture as well. Secret int x, that's the prototype, and then you basically say num is equal to 5, num is equal to a is equal to 2 plus secret num, c out a, secret a. So here's a function you call secret a. Here in this case you are actually adding a into the secret num, and this is the body of the function. If x is greater than 5, return 2 into x, otherwise return x. And we saw that if this return x is not returned, the problem is that we expect an int to be returned. However, if x is less than 5, then no int is going to be returned. It does not return anything actually. That's a problematic point. So we must return something even if the value is otherwise. Okay, so let's go to the global variable declaration now. In the global variable, we notice that int t is declared globally, and hence it's accessible anywhere in the func1. So if you want to use t here, for example, like this change will be made to the actual t. It's the same as if you use something by address, this change will be made to the actual a. So when you call func1, the changes are made in t, right? You first increment it by 12. So t is going to be incremented by 12. Then what you perform is t is equal to t plus 13. So the initial value of t, whatever that was, t was assigned as 15 as the initial value. So you'll notice that the initial value is 15 at the start. When you call this, the value is still 15. You can increment it by 12, it becomes 27, right? And after it becomes 27, you basically have the value of t in function a is equal to a and t is equal to this. So a is the same as t. So 27 is equal to 27. Then you actually increment it by 13. So now 27 plus 13 is 40. So a will also become 40 and t will also become 40. And then you basically go return from the function func1 and you output the values 40 finally for t and you return. So let's check what's happening here, right? So in here, I noticed that the initial value is 15. It is 15 here. So once it enters the function over here, it's still 15 and 15 for a and t, perfectly fine. Then you add 12, so it becomes 27 for both a and t because this is the same address they're pointing to. From 27, it becomes 40 and 40 for both t and a because it's the same address they're pointing to. And finally, you return the value 40 here, you return, and again the value 40 and 40 is observed. The change is permanent for t. So that's the whole program. In this case, you need to understand the main concept here is function call by reference, and we need to understand what's happening and the scope of a global variable. The t is a global variable, so it works exactly the same way. It's accessible here. Every change in t is made in t, in the real t as well. So let's go to the larger. Again, two functions, larger and compares 3, and this one compares actually perform some kind of comparisons for larger functions and for compare 3. Again, this is a function that contains a single line. Notice that. And this one is basically compare 3 is calling the larger function as a x larger and larger of x and larger of y and z. Notice that this one is also a function. So larger expects two integers, two doubles. So this is expecting in the prototype, we can see it is expecting two doubles. The compare 3 actually gets 3 values input and compares them all, right? So here's what it does. It basically says that first compare y and z. So this is the inner parameter. Whatever is returned, whatever is larger, if it is the larger value should be returned here, and then compare that larger value with x through the same mechanism too, and then basically this one then returns the best of x and the larger value of y and z. And whatever is larger will be returned finally as a result of compared 3. So in the main, we can notice that, for example, let's say double 1, 2, 5 and 10, larger of 5 and 10 is 10, larger of, again, input two numbers from the user. Then you basically enter the larger of 1 and 2 is larger of 1 and 2. Then you can basically enter three numbers, 43.48, 34, and 12.65, and we give you the larger of three numbers. So let's run the code to get a better understanding of what's going on. So enter two numbers, of course, larger number of 5 and 10, the function is running absolutely fine, we're sure about it. So let's see the large number of 5 and 10. Yeah, let's get the large number of two numbers. Let's go for 140 and 120. The largest number of both is basically 140, that is right. Then the largest number of 43.48, 34, and 12.65 is 43.48, which is also right. Here you notice that we called a function as a parameter. So larger x, y, z was a function that that was called as a parameter to the to this particular function larger on its own. Anyway, let's go to the largest one. In the largest one, here is the thing. We this program finds the largest number of a set of 10 numbers. So you enter 10 numbers and it wants to find the largest one of them. So in this case, this is a relatively simple program. You can use a for loop starting from 1 going till 10, find the larger and store that in the max. So larger of max is the first number, whatever you enter, and after that, everything you enter, the larger one is stored in the max. And finally, you output the value max. That's it. So this is a really simple function, which demonstrates the use of return as well as of calling the function. So let's go to the exercise 16. This formula calculates the total time spent by an employee on the job. To run the program, enter y. Okay, we do this if the response is y. And again here, cin.get You know this function. This is basically from the input output function. You might know this already. And you want to store it in discard, whatever it is, character. And finally, if the value is, if the response is y here, we then move on to employee name and other stuff. Y is equal to y if it's true, false, departure R, departures before this, departure aim, departure time, time on job. So how much time is, if you get the arrival time, arrival hour, arrival minute, arrival aim, departure time, departure minute, etc., you can basically pass to this function to calculate all these things for you. This is not problematic. And in here, here's a funny thing. So if you notice, there is this function prototype that is mentioned here, time on job, arrival this and this. So this is something that is going to cause an error, I think. If you run the code, look, here's the error. Because you cannot declare a time on job, a function body or function thing inside a function. Inside the function, you cannot. However, if you can comment it out like this and like this, right, save it and run code again. I think now this should run absolutely fine and ask for input or something. Okay, some more errors here. I think time on job in minutes. There is something else. Oh yeah, for of course. Where's the if here? The if is missing. You cannot have a dangling else if and so on. So there are other errors here as well. If we need to probably fix or something. Yeah, so this is some problem with the how to correct this program. Find as many errors as possible. So this is something for you to do. I'll not do it for now. Let's go to the next example, which is return statement. This program will state that a value returning function returns only one value, even if the return statement contains more than one expression. This is a legal, but not a recommended code. Return two values here, the value of x will be returned. The value return two values here, only z plus p will be returned. This is what we have seen already, and this is what is exactly happening here. So I'll just move on. You can run it on your own. Similarly, if we talk about this particular piece of code, again, something similar. Enter feet in that, blah, 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 meter and inches into feet and inches conversion program. Again, has show choices, feet and choices in meters and, meters and sent to feet and inches. So these are all different functions that perform a particular task. We can call them in during the switch statement. We can use the show choice function. We use a do while loop here. That's an interesting part. So all of these things you have studied in the previous lecture, again, go through this. The values that are going to be changed will only be changed here. So this is the value that is going to be changed. This is the value that is going to be changed. This is the value that is going to be changed. And this is the value that is going to be changed. However, MT and CT, F and inch will not change at all. Similarly, show choice is a function that does not have any parameter and that does not return any parameter either. Let's go to the next example quickly. It's a cable company billing program which creates and prints a customer's bill for a local cable company. So we made this program earlier, if you remember in the previous lectures. In this case, we just call the residential function or the business function, and these are the two functions which calculate the values for us. So this is how a function can be used or should be used actually to simplify our main program or other programs. Let's go to the other example, which prints a triangle of stars. And this is a program that takes in some things. It prints stars and uses for loops to print it. Let's go to the next example. The next example is a program that illustrates how a value parameter works. A value parameter actually copies it, and the original value here will retain the same. Even after calling the function, the number is going to be the same. However, within this, the number is changed, and it will be changed here locally, but it is not going, even if the number, if I use the name number here, it still refers only to this number. It's not the same number. You should remember that. That's the trick that you must always remember. A number here will always be different from the number is. This is a copy. This is not the same. Even if the name is same, it's not still not the same number. Okay, let's go to 6-13. This program reads a course score and prints the associated course grade. And again, we're going to use, look how small this main function is. In course score, you see out that you get score, you print grade, and you return. That's it. Everything else is being done over here in the different functions. This makes code much more readable, much more easy to understand. Once you understand functions, this is really nice. So let's talk about next example. This is a reference and value parameter differences. And again, you can see that here's a function function one, which has an value parameter and two reference value parameter, reference parameter, and a value parameter. This is one that has a reference parameter, a value parameter, and a reference parameter. And whatever is in reference will change actually in the main as well. Whatever is in value will not change in the main, but only change in the local version here. That's a value parameter for you. Let's go to the next example. It's a reference and value parameters again. It makes you think something. Again, the concept is same. The thing that will change only. For example, in ref, the value will change, but the value will not change. In 1 and 2, the value will not change whatsoever. The values will change in both first and second. Although the code is exactly the same, but the values will change depending on which function is called and which parameter is being used. That's the main thing. So this is static and automatic variables. So we can see that this is a static variable, int x is equal to 0. And if this is static, this means that the value that gets changed will be retained throughout. So x equal to x plus 2, y is equal to y plus 1. Inside test, x is equal to and y is equal to this, right? So that's inside test, this is true. So if you change the values, you'll see that the static variable values will change continuously. Let's just run it and let's see the effect of static and automatic. Okay, it's unable to find this because what? Come on, I have this file there, right? Cool. Okay, never mind. I think I'll not just execute it for now. Let's go for 6.19, and it's again a different program, again two functions, and you need to see the function return type and stuff, how they're called. The same name, so the same name, this is what we call as function overloading. Same name, but different, either different set of parameters. So this is one parameter, two parameter, or three parameters, or at least different types. That's the thing. So yeah. Notice that here is where if we run this program, this is going to give an error because it cannot find the function volume. Actually, it can because these are the default parameters. So default value of length L is 1, W is 1, H is 1. If you don't pass it parameter, the volume will by default will be 1. If you pass it some parameters, then it's going to change those ones, whatever you specify, but there has to be specific order. So everything that is not passed, left of everything else will be missed as well. Sorry, right of everything else will be missed as well. So let's go to the next function. This one is how can we use a predefined function. So here we use power, is lower, to upper, and other functions as well. Power, power, power. So these are all predefined functions. They are all in yellow here, as you can see. And this is how you can make the function calls for a predefined function. Notice that we include the corresponding library CC type, CMath, IOStream, and IOMan, IP, etc. Let's go to the next example. This is a simpler example, which is again simply using a function, int main, int test score, and return 0. The problem here is since there's no function call being made, we can never assign a grade, even if we have a valid test score. So this is going to show nothing. On the other hand, if we make this thing, this is the one where we are going to roll a dice. So we roll a dice. Here is how we can use a built-in function called srand times 0. So we initialize it with a random number, and this is where a random number actually gets generated. So if you have to perform a random event, you need to use srand and rand library, rand function calls. And these are both available in the library cstdlib and ctime. Ctime is for time 0. Srand and rand come from the cstdlib, and this is important for you to understand and analyze. Let's go to 6.5. Where we calculate this Nth Fibonacci series. Again, this is a program that we've done before, but now we're going to use a function for performing it in first, second. This is all written out in a function. The only thing here is that the function for Nth Fibonacci is not shifted here, so it becomes easier for us to read the main at this point and differentiate between the actual function that calculates the Nth Fibonacci and the other pre-processing part that is being done in the main. So taking the same example, and here's an interesting example. How do you calculate if a number is if a string is a palindrome or not? What is a palindrome? A palindrome is a number that has is a string that has what you call, for example, madam, M-A-D-A-M. If you reverse it, it becomes the same, right? So madam in reverse is also madam. That's what we call a palindrome. Anything in reverse is exactly the same. How do you compare if a string is a palindrome or not? To do that, all you need to do is to come up with a function. Bool is palindrome. It takes as input a string str. The length of the string is calculated first. So if the length is basically, let's start from I is equal to 0. I is less than length minus 1 divided by 2. So you want to take one length less and divide it by 2 until that point, until the middle point, increment the I. And here, if string I is not equal to string length minus I and 1 minus I, right? So the opposite side of it, if both strings are not matching, then return false. If we run through the whole loop and we didn't have a return statement at all, this if never became true, right? So if the two things were matching throughout till we reach the center point until here, length minus 1 divided by 2. At that point, if everything is still matching, then we return that it is indeed a palindrome. A simple function that performs a really complex task. You need to understand this function a lot before you can actually start to run it and execute it. So this is something that you really need to understand before moving ahead. This is the point that I want you to stop and look at the code, look at the beauty of the simple code. This performs a really complex task in a simple algorithmic way. Both a palindrome is something where everything, if you reverse it, everything is matching, right? But the idea is simple. Every character at the start should match with every character at the end in the same order until you reach the middle of the characters. And at that point, you need to stop and it's already a palindrome. But here's the issue here is in main call, we didn't call the function palindrome, and hence the function palindrome will not be called because there's no one calling this function palindrome. You have got the prototype here, but the prototype does not call the function. The function call has to be made inside the main or a function that is being called by the main. Or yeah, as long as deep as you can go down. So this is the last example here. This is a program that calculates second degree polynomial factorization. Factorization is done for these things. You can see some of them are passed by reference, others are passed by value, and the value ones will not change. The ones that are basically given here will change, and that's the whole program in a nutshell. We're using some built-in functions. We perform factorization again by using some built-in functions. This is the maths behind the algorithm behind factorization, and this is something that you need to kind of get used to making algorithms of such kind in your exams and in your course projects. So with that, I think we are reaching the end of chapter 6, the predefined functions. And I hope that today's lecture was very interesting to you. The thing is that in today's lecture, we basically covered the whole of chapter 6, which is the predefined functions. And in the next chapter, I'd want to work with some of the user-defined simple data types, namespaces, and the string type. And this will then be followed by arrays and strings that we have done so far. And up till when I covered that, those two chapters or pre-mid topics will be covered completely. After that, I'll start with something with some of the more complex topics. For example, pointers, maybe. But of course, pointers are in chapter 12, and I'll kind of work only with that part that is related in this course. So it will be part of chapter 12. We'll then talk about chapter 13, which is overloading and templates in quite a lot more detail before talking about chapter 14, which is exception handling. And I think that's, and of course, chapter 15, which is recursion. So those are some of the topics that you need to work hard on. So those 3 or 4 chapters will be new. Otherwise, everything will be pre-mid topics for you. So with that, I hope you've understood each and everything, and we have made sense in this particular lecture. So I'll now discuss chapter, I think, 8 with you in the next class. Till then, take care and see you in the next class. Allah Hafiz.